I want to make a Hall effect thruster with no experience whatsoever. This is day 8. Last time, we learned that the general formula for thrust is the mass flow rate times the exit velocity. So now, let's see how we can modify this for Hall thrusters. Remember that an ion is an atom with charge, and Hall thrusters generate propulsion by expelling ions at very high velocities. So, to calculate your mass flow rate, it's equal to the discharge current times the mass of your ion, all divided by its charge, which generally is equal to the charge of an electron. One way to think of this is with the analogy of the shower head from the previous video. The ions are essentially the water molecules, and the current is the flow of water through the shower head. Now, calculating the exit velocity is a bit tricky to explain, but it's essentially derived from the kinetic energy of your particle, 1/2 mv squared, and setting that equal to the discharge voltage of your thruster times the charge of each ion. Trust me, all the units work out, so just remember this one equation. Putting the two parts together, you get this equation for thrust. Now, in order to calculate the voltage and current for this equation, you simply have to choose a power level for your thruster, let's say 500 watts, and from what I've read, I've seen that 300 volts is a common voltage for Hall thrusters of this power, and you can simply calculate the current from P equals VI. Using this, and assuming our propellant gas is argon, we get a thrust of 26 millinewtons. This might seem like quite a small amount of thrust, but where electric propulsion lacks in thrust, they more than make up for it with specific impulse, which, if you're interested in learning about that, stay tuned for day 9, and until then, see you soon.